Hello guys, so welcome back. This is Mr. Soto talking to you guys about Algebra 1 for the STAR test. Okay, so those of you that are in my class, you guys have been studying this. Today in this video we're going to be talking about domain and range. Okay, I've looked at the domains and there's a lot of topics, a lot of questions that are talking to you guys about domain and range. So in this example we're talking about linear functions. It says here, determine the domain and range of a linear function in mathematical problems. Determine reasonable domain and range values for real-world situations, both continuous and discrete, and represent domain and range using inequalities. So as you can see here, the A.2a, that TEKS covers a good amount of examples that you're going to see. And in the past, they have asked a lot of questions on domain and range with this TEK. So let's take a look at this example right here. It says here that a part of a linear function is shown on the grid. So here's a straight line. This is a linear function, and only a part of it was shown. If not, it would have continued forever. What is the range of the part of the linear function shown? The range. They're asking you for the range. So in order for you guys to understand domain and range, you first have to understand that domain has a letter assigned to it, and the range has another letter assigned to it. So for those of you that forgot or don't know, we know that the domain goes with the letter X and the range goes with the letter Y. Okay? So here they're asking you about the range. It seems like the letter we're going to be looking at is the letter Y. That's the important letter right now. We don't really care about the domain because they're not asking you about the domain. So because the domain's not important, then that means the x-axis is not important, and neither or any of these numbers are important. Okay? So we don't need to look at those numbers. All we need to worry about are the range values. The range is the y values right here. And the y values are going to be located right here. Okay? So I'm going to go ahead and circle this. Okay, so that's what we're looking at. So how do you determine the range of this function? If you look at this point, it looks like it is aligned with the number 2. And if you follow the line, this entire line stops right here, and this number is going to be located at -4. So we know that the range of this piece of this function is located between 2 all the way down to -4. Or in math, we go from least to greatest, so it's from -4 up to 2. So we can say that the range, the y values, is going to be between, okay, y is going to be greater than a certain number, but it's also going to be less than another number. And the number that it is greater than is going to be -4, but it's going to be less than 2. Okay, y, which is the range, is between -4 and 2. However, you notice that the circles here, this circle right here is closed, and this circle right here is open. When you're dealing with inequalities, guys, the circles are important, okay? So in the other video, I talk about inequalities and the open and closed circles. So because this circle right here is closed and it's aligned with the 2, then in our answer, we should have a line at the bottom like this. On the -4, you don't have to include the line because the -4 has an open circle. And we know that open circles do not have the line at the bottom. So right here, we're going to leave that the way it is. So the range of this example would look something like this. What is the range of the part of the linear function shown? It's going to be between -4 and 2. And it includes the 2. It does not include the -4. Okay guys, so in this example we're talking about, there's a whole paragraph up here and they're talking about flowers. We're still dealing with linear functions because if you look at these points, it is in a straight line, okay? But they're just not connected. The flowers will use no more than 8 bouquets for the wedding. Which set best represents the domain? They're asking you here about the domain of the function for the situation. Okay, so instead of the range, now they're asking you about the domain. And if you remember, the domain is the x, not the y, okay? So because they're asking you only for the domain, we can cross out the y. We don't need this. We don't need these numbers right here, okay? All these numbers, it's just going to try to distract you from getting the right answer. In my opinion, just go ahead and scratch them off. Don't look at them. You can only worry about these numbers. This is the domain. So all we need to do is figure out the domain, the values of the domain here. If you start with this first point, the value that it's on right now, it's a 0. So we can say that x is going to include a set of numbers, and that's going to be 0. If you follow this next point right here, this point is not on the line, but if you look at the interval here, it's going from 0 to 2. This point happens to be right in the middle of 0 and 2. So right here you're going to have a 1. Then you can include the 1 as part of the domain. The next point right here is on the 2. The next point right here would be between 2 and 4, which again is 3, and you just keep going. This is 4, 5, 6, 7, 8. So you can continue the pattern. And this would be your answer, guys. The domain, which is the x values, is going to consist of a set of the numbers 0 through 8. All these integers, okay? Nothing to do with the y, okay? Just the x values. If you take a look at this example, guys, they're asking you about domain and range. So they're asking you for both things. And not only are they asking you for both things, they're giving you an inequality problem, okay? Which the TEKS covers all this. And if you look at the answer choices, they're showing you the graphs. And graphs are nice because you can actually see what's going on here. So the domain and the range of part of a linear function R are given. Here it says that x is greater than 5, y is less than 2. Which graph could represent this part of linear function R? So which one of these functions could represent a part of linear function R? So let's go ahead and take a look at the rules. These are the rules that they're giving you to represent this part of the function R. And if you remember, I'm going to abbreviate domain with the D. So domain is going to be the x. The range is going to be the y. Now, they're telling you that the x is greater than 5. So if you remember that the domain goes like this. The domain is the x-axis, guys. Remember, the domain is going left and right. And they're telling you that x is greater than 5. Remember, this symbol right here means greater. So you gotta imagine the number line here. If the middle of this line is 0, then we know that 5 is 5 units to the right. So let's pretend that the I is the 5. And we're trying to find the numbers that are greater than 5. Greater numbers are always going to be on the right side, guys. Every time you're on the number line, the further right you go, the bigger the number gets, no matter where you are on the number line. So we know that the domain has to be going in the right direction. It has to be going this way, okay? Because it has to be greater than 5. It has to be moving to the right side. Now let's take a look at the range. It says here that the y, this symbol means less than. This is greater than, and this is less than. So y has to be less than 2. Okay, so the range is the y-axis. Remember, range is the y, so it goes up and down. I should probably do this in red. So the range goes up and down, right? This is the y values. And they're telling you that the y has to be less than 2. So just like the horizontal x-axis, greater is to the right, less is to the left. On the y-axis, the higher that you go, the greater the values. The lower that you go, the lesser the values. Here, we want to go less than 2. So you kind of have to figure out that you're going to be moving downward. So less means down. And so we're going to be moving down from the 2. And we know that the 2 is above the x-axis. So it's going to be 2 units up, and we're going to be moving in a downward direction. And based on the domain, we're going to be moving in the rightward direction. So we're looking for a graph here that shows us an arrow that is moving to the right and down. Well, if you look here, this one's moving to the opposite direction, guys. This is going to the left and up. So this one's automatically wrong. It's wrong in both directions. This one is showing us that it's moving down and left. But we don't want to be moving to the left. We want to be moving to the right because x is greater than. Greater means to the right. And in the y-axis, less means down. So this one's going down, that's good, but it's moving in the wrong direction, moving over to the left. Now, to move the screen, I'm going to have to erase all this. Here, if you look at this one is moving slightly to the right, which is good. We want it to move this way. And it's also moving in a downward direction. So this one checks off both directions. It's moving this way, and it's moving this way. So that's good. And now this one is moving to the right. That's good. But it's moving up. We don't want it to move up. We want it to move down. Because remember, y is less than 2. This one is showing that it's going up. Number 7, number 6, number 5, these y values are actually going to be greater. 5 is greater than 2. We don't want this. We want y to be less than 2. So we want these numbers over here. That's why this is wrong. So the only answer that was correct here, guys, was letter B. I've already shown you 3 quick examples on domain and range, okay? And they're showing you in graphs like this with inequalities. They're showing you in points, and they're only asking for the domain. They could also just ask you for the range, or they can ask you for both. And in a linear function like this, which is getting cut off at the ends. And when that happens, you have to look at the circles. If it's going to be an open circle, it does not include the number. If it's going to be a closed circle, it includes the number. So this is just linear functions. Right now in the next video, I'm going to show you guys about quadratic and exponential functions.